Students, now we will start with your exercise 5C. This is based on the divisibility rules. Divisibility rules. Now, already some of the rules you have learned in your previous class. So, some old rules which you have already learned, that we will also revise, and we will do some new rules also. Okay, so find divisibility rules. So I'll start with the question first. In this, find the numbers that are divisible by the ringed number. So as you can see, the numbers given are these, and in the ring means in the circle, in this ring they have given you the number 2. It means I have to see whether all these numbers are divisible by the ringed number is 2, so I have to see whether these numbers are divisible by 2. Now what is the divisibility rule of 2? You must be knowing that all even numbers are divisible by 2. Now what are even numbers? Even numbers are those numbers which have 0, 2, 4, 6, 8 at its ones place, at the end of the number. At the end of the number, if you have 0, 2, 4, 6, 8, they are even numbers. As you can see, these are the multiples of 2. So all the numbers which are multiples of 2, they are even numbers. So all even numbers are divisible by 2. Now if I will look at these numbers, I will look at the last digit 9. Is this a multiple of 2? Is this an even number? No. So this means this is not divisible by 2. Now this is 4 at the end, and 4 if you have at the end, it becomes an even number, so this is divisible by 2. Now if this 3, this is odd number, 3 is odd number, so this whole is an odd number, so this is not divisible by 2. Now look at the last digit in this 6, which is an even number, a multiple of 2, so it means this whole number is divisible by 2. So these two numbers which are even numbers, because they have 4 and 6, which are the multiples of 2, which they have 4 and 6 at its end, so these two numbers are divisible by 2. But these two numbers are odd numbers because they have odd digits at the end, so these are not divisible by 2. Now if you will look at the B part, the numbers given are this, and in the ring the number is 5. Now it means I have to check whether these numbers are divisible by 5. Now what is the divisibility rule of 5? It says if a number has 0 or 5 at its ones place, at its end, the numbers having 0 or 5 at its end, they are divisible by 5. Now look at this number is having 0 at its end, so this number is divisible by 5. This number is not having 0 or 5 at its end, so this is not divisible by 5. Now this number is having 5 at its ones place at the end, so this number is divisible by 5. But this number is not having 0 or 5 at the end, so this number is not divisible by 5. So which numbers are divisible by 5? The numbers which have 0 or 5 at its ones place, that are divisible by 5. Now C part, in the ring you can see is 10. It means I have to see whether these numbers are divisible by 10 or no. So, and what is the divisibility rule of 10? All the numbers which have 0 at its ones place, 0 at ones place at the end, if you have 0, then the number is divisible by 10. So does this number have 0 at the end? No, so this number is not divisible by 10. This number has 0 at the end? Yes, so this number is divisible by 10. Does not have 0 at the end, so this number is not divisible by 10. This number has 0 at the end, so this number is divisible by 10. Now we come to the D part. In the D part, if you can see, in the ring is given number 3. It means all these numbers I have to check whether these are divisible by 3 or not. Now what is the divisibility rule of 3? The divisibility rule of 3 says that if the sum of all the digits of the number is divisible by 3, then the number is divisible by 3. Now what it means is that sum of all the digits. Now if I take 133, what I will do is I will take the sum means add. I will add all the digits of this number, 1 plus 3 plus 3. So what do you get? 7. You get 7. The sum comes 7. Now this 7 is not divisible by 3. Now this sum which I have taken of all the digits is not divisible by 3. So if this sum is not divisible by 3, it means this 133 is not divisible by 3. Okay, now let me take the second number, 321. So what I will do, I will add all the digits, 3 plus 2 plus 1. What do you get? 6. Now is this 6? This 6 is divisible by 3? Yes, because 3 2s is 6. So this 6 is divisible by 3. So this 6 is divisible by 3, so it means this number is divisible by 3. Okay, now let me take the next one. If you will take the next one, 4 7 1 3. So what I'll do, I will take the sum of all the digits. जितने भी इसके digits हैं, I will add them up. Now 7 and 4 11 12, it comes 15. When I added all the digits of this number, the sum is 15. Now is this 15 divisible by 3? Yes, because 3 5s is 15. So this 15 is a multiple of 3. So because this is divisible by 3, it means this number is also divisible by 3. So this is how we check whether the number is divisible by 3 or not. Now let me take the next number, 2 plus 6 plus 4 plus 0. So all these digits I will add, 2 plus 6 plus 4 plus 0. So that comes to be and 12. So now is 12 a multiple of 3? You get 12 on the table of 3. Yes, 3 4s are 12. Yes, on the table of 3 I get this 12. So 12 is a multiple of 3. It means this number also is divisible by 3. Now I come to the second question. In the second question, they have given you some number. I have taken the A part and a few numbers from the A part. They are saying which of the following numbers are divisible by 9. Now what is the, I have to find the divisibility test of 9. I have to find whether these numbers are divisible by 9 or no. Now what is the divisibility rule of 9? It is just like 3. Like sum of all the digits of the number is divisible by 9 this time. Same rule as I had for 3. So that when we take out the sum of all the digits in 3, while checking for 3, that sum should be divisible by 3. Now for 9, I will follow the same steps, means I will add the digits. Like if I take 108, 1 plus 0 plus 8, what do you get? 9. Now this 9 I have to check on the table of 9. So is this 9 divisible by 9? Yes. So it means this 108 is divisible by 9. Now let me take the next example, 387. So what I will do, I will add all the digits, 3 plus 8 plus 7. So what you get? 18. So is this 18 divisible by 9? Yes, 9 2s is 18. So this 18, this when I took out the sum of all the digits, this 18 is divisible by 9. It is a multiple of 9. So it means 387 is divisible by 9. Now let me take the next one. It is 4609. So 4 plus 6 plus 0 plus 9. What you will get? 10 and 19. Now look at this, 19. Do you get 19 on the table of 9? Is 19 a multiple of 9? No, 9 twos are 18 and 9 threes is 27. So we don't get 19 on the table of 9. 19 is not divisible by 9. So what it means is this number is not divisible by 9. Now, third question, A part, they are saying in each of the following, find the numbers that are divisible by the first number. So, the first number given is 4. So, I have to find whether all these numbers are divisible by 4. Now, first of all, what is the divisibility rule of 4? So the rule says if the number formed by the last two digits is divisible by 4, then the whole number is divisible by 4. So let me explain you this. I'll take 212. They are saying if the number formed by the last two digits, what are the last two digits? 12. Okay, now do you get this 12 on the table of 4? Means is this divisible by 4? Yes, 4 3s is 12. So I will see the last two digits. If they are divided by 4, it means this number is divisible by 4. Now 12 is divisible by 4, 4 3s is 12. So it means this number is divisible by 4. Now let me take the second number. It's 1358. So what I will do, I will take the last two digits. The last two digits are 58. Now let me divide this by 4. 4 ones are 4 and 4 fours are 16. So remainder I get is 2. So is this for 58 exactly divisible by 4? No. So because I am getting the remainder 2. So what it means is that these two last digits are not divisible by 4. So this means this number is not divisible by 4. Okay, now let me take the next number 4656. So what I have to do in order to check for 4, I will take the last two digits 56 and divide this with 4. 4 ones are 4 and 4 fours are 16. Yes, I don't get any remainder. So it means 4 14s is 56. It means the last two digits are divisible by 4. So what it means is that this whole number is divisible by 4 because the last two digits are divisible by 4. Now the question number 4a part, in the first number is given 6 and I have to find out whether all these numbers are divisible by 6 or no. Now what is the divisibility rule of 6? The divisibility of the rule of 6 says if the number is divisible by both 2 and 3, अगर वो जो नंबर है it is divisible by both 2 as well as 3. So it should be divisible by both 2 and 3, then only it will be divisible by 6 also, like 2 and 3. So if I multiply 2, 3 is 6. Yes, so these are the prime factors of 6. 2 and 3 are the prime factors of 6. So in order to see whether the number is divisible by 6 or no, I will check whether the number is divisible by 2 and 3 both, then the number will be divisible by 6 also. Now look at the 45, first number 45. First of all, with 2. Now is this number divisible by 2? No, not with 2. Not divisible by 2. Why? Because this is an odd number. इसके पीछे 5 है which is odd, so this number is odd. So odd numbers are not divisible by 2. So if this is not divisible by 2, now let me check with 3. What is the divisibility rule of 3? 4 plus 5, I have to add the digits 9. So it is divisible by 3 but not divisible by 2. So will it be divisible by 6? No, not by 6, by 6, because the rule says that it should be divisible by both 2 and 3. This number is divisible by 9 but not by 2. So this number is not divisible by 6 also. Okay, now let me take the second example, that is 504. First I have to check with 2. Is this number divisible by 2? Yes, because the last digit is even, is a multiple of 2 and this is an even number, so it means this is divisible by 2. This is divisible by 2. Now let me check with 3. So in order to check for 3, what I have to do, I have to add all the digits. 5 plus 0 plus 4 is 9. So 9 is divisible by 3. Okay, so this number is divisible by 2 also, so this number is divisible by 3 also. So it means that for 504 will be divisible by 6 also. So because this number is divisible by both 2 and 3, so it means this number will be divisible by 6 also. Now let me take the next example, 1230. Now is this number divisible by 2? First of all, I have to check with 2. Yes, because it has 0 at its ones place and this is an even number, so this is divisible by 2. Now for 3, 1 plus 2 plus 3 plus 0, what do you get? 6. So 6 is divisible by 3. It means this number is divisible by 3 also. Divisible by 3 also. So this number is divisible by 2. This number is divisible by 3. So it means that this number is divisible by 6 also. So I have seen that these two numbers are divisible by 2 as well as 3. So it means they are divisible by 6 also. But this number was divisible by 3 only but not by 2. So it cannot be divisible by 6 also. Now question number 4, B part. In the first number given is 12. It means I have to check whether these numbers are divisible by 12 or no. Now what is the rule of 12? Divisibility rule of 12. The divisibility or rule of 12 says if the number is divisible by both 3 and 4. So as you can see, 3 4 is 12. If the number is divisible by both 3 and 4, then the number is divisible by 12 also. Now let me do this first one, 112. So first of all with 3. So what is the divisibility test of 3? 1 plus 1 plus 2. I have to take the sum of the digits. 2 plus 1 plus 3 is 4. Is this 4 divisible by 3? No. So this means that this number is not divisible by 3. Okay, but if I take the last two digits in order to check for 4, I have to see the last two digits. The last two digits are divisible by 4. So this number is divisible by 4. This is divisible by 4 but not by 3. Okay, so it means this number will not be divisible by 12 also, because this number is not divisible by 3, though it is divisible by 4 but not by 3. So it means this number will not be divisible by 12. Okay, now let me take the next example, 1344. So I have to first check with 3. So what is the rule for 3? I have to take out the sum of all the digits. 12. So is this 12 divisible by 3? Yes. So it means that 1344 is divisible by 3. Okay, now for 4. What is the divisible test of 4? I have to check the last two digits. If they are divisible by 4, 4 ones are 4 and 4 ones are 4. So yes, these last two digits are divisible by 4. So it means that 1344 is divisible by 3. 1344 is divisible by 4 also. So it means that this number will be divisible by 12 also. So in this, the number in this 112, the number was divisible by 4 but not by 3. So it won't be divisible by 12. But this number is divisible by both 3 and 4. So this number will be divisible by 12 also. Now we come to the C part of the fourth question. In this, you have to check whether the numbers given are divisible by 15. So the first number given is 15 and we have to check whether the other numbers which are given, they are divisible by 15. Now what the divisibility rule of 15 says, that the number is divisible by 15 if that number is divisible by both 3 and 5. Now 3 and 5, when you multiply 3 and 5, you already will get 15. 3 5 is 15. So 3 and 5 are the factors of 15, the prime factors of 15. So if the number is divisible by both 3 and 5, then the number is also divisible by 15. So let me check the first number, 45. So I have to first check with 3 what is the divisibility rule of 3, that I have to add the digits. 3 and 4, 4 and 5 is 9. So and this 9 is divisible by 3. 3 3s are 9, so it means that 45 is divisible by 3. Okay, now to check with 5, what is the divisibility rule of 5? That a number should have 5 or 0 at its ones place. Now this number is having 5 at its ones place. It means that 45 is divisible by 5 also. Now this 45 is divisible by both 3 and 5. It means it is divisible by 15 also. Is that clear? So because this 45 is divisible by both 3 and 5, so it means this is divisible by 15 also. Now let me take the second number, 47322. Now first I will check with 3. So in order to check with 3, what I will do, I will add the digits of this number. So 18. So this comes to 18. So is this 18 divisible by 3? Yes, this 18 is divisible by 3. 3 6 is 18. So it means this number 47322 is divisible by 3. Okay, now to check with 5. What is the divisibility rule of 5? That the number should have 0 or 5 at its ones place. Does this number have 0 or 5 at its ones place? No. So 47322 is divisible by 3 but not 5. 5 but not by 5 because it doesn't have 0 or 5 at its ones place. So what it means is that this number is not divisible by 15 because this number is not divisible by 5, though it is divisible by 3 but not divisible by 5. Therefore this number will not be divisible by 15 also. Now the D part of the fourth question, the first number given is 18 and we have to check whether these numbers are divisible by 18 or no. Now what is the divisibility rule of 18? It says if the number is divisible by both 2 and 9. 2 and 9. When you will multiply 2 into 9 is 18. So both these are factors of 18. So if the number is divisible by both 2 and 9, it means the number is divisible by 18 also. Let me take the first number, 216. Is this divisible by 2? First of all, I'll check with 2. Is this divisible by 2? Yes, because it is an even number. How do we know? We check the last digit, 6. 6 is the multiple of 2. 6 goes on the table of 2. So it means this is an even number and therefore 216 is divisible by 2. Now with 9, how do we check with 9? We add the digits, right? We add the digits of the number 6 and 1 7 and 2 9. Now is this 9 divisible by 9? Yes, 9 ones are 9. Now this 216 is divisible by 2 and this 216 is divisible by 9 also. So what it means is that this number will be divisible by 18 also, because this number is divisible by both 2 and 9. So it means this number will be divisible by 18 also. Now let me take the next number, 74214. Now first I will check its divisibility by 2. Is this number divisible by 2? Yes, because this is an even number. How do I know? I look at the last digit. The last digit is even. It goes on the table of 2. It's a multiple of 2. 2 2s are 4. So I said all the numbers which have 0, 2, 4, 6, 8 at its ones place, they are divisible by 2. So this number is divisible by 2. So 74214 is divisible by 2. Okay, now I have to check the divisibility by 9. So what is the rule? I have to add all the digits. I have to add all the digits. it comes 18. Yes, 18. Now is this 18 divisible by 9? Yes, 9 twos is 18. So it means this 74214 is divisible by 9 also. So this number 18 is divisible by 9. So it means that this number is divisible by 9. So now both the numbers are the numbers are divisible by both 2 and 9. So it means that 7214 will be divisible by 18 also, because it is divisible by both 2 and 9. So it is divisible by 18 also. Now we will start with the fifth question. In the fifth question, you are given numbers and you are asked to check whether the following numbers are divisible by 11. Now, first of all, what is the rule of divisibility rule of 11? The rule says find the sum of digits at odd places. So, sum of digits at odd places, sum of digits at even places, and then you have to subtract them. If the result is 0 or a multiple of 11, then the number is divisible by 11. Now let me explain you this by taking the numbers. Like first number given is 178. Now they are saying find the sum of digit at odd places. So what are odd places now? Now what I will do is starting from the right, like starting from 8, I will give them places. I will say that 8 is at the odd place, the next one is at the even place, and then again at the odd place. So alternate digits I will take, like odd, even, odd. Okay, like this, odd, even, odd, even, odd, even, like this. I will give them the places. Okay, now what it says is find the sum of digits at odd places. So which are the odd places? 8 and 1. So I will find the sum of these digits. 8 and 1 is 9. Okay, now sum of digits at even places. At even places there is only one digit, no other even places there, so that is 7 only. So sum of digits at odd places is 9, and sum of digits at even places is 7. Now we have to subtract them. So I will subtract both of them. So 9 minus 7 is 2. So what is the result? The result is 2. But they say if the result is 0 or a multiple of 11, then the number is divisible by 11. So now when I subtracted the sum of digits at odd places and sum of digits at even places, when I subtracted them, the result was 2. Now this is neither 0 nor a multiple of 11. Nor it is divisible by 11. So what it means is that 178 is not divisible by 11. Now let me take one more example, the second number, 91718. Now what I have to do, I have to assign them places, like starting from the right, from the ones digit. So what I will do, I'll give this as an odd place, then even, then odd, then even, then odd. Okay, so this is how we assign the places for them. The first I will keep at odd place, then even, odd, even, odd. Now what the rule says is sum of digits at odd places. So which are the digits at the odd places? 8, and then 7, and then 0. So these were the digits at odd places. Sorry, this is 9. 8 plus 7 plus 9. So what do you get? 24. Okay, now second step is sum of digits at even places. Now which are the digits at even places? 1, this is even place, this is 1. So it comes to be 2. Now I have taken out the sum of digits at odd places, sum of digits at even places. Now I have to subtract them. So when I subtract, I get 22. Now is this 22 a multiple of 11? Is it divisible by 11? Yes, 11 2 is 22. right? So this 22 is divisible by 11. So it means that this number is divisible by 11. Divisible by 11. Now let me take one more example. I can take the number, a big number I will take. Let me take 93808. So what is the first step? I will put them in odd and even places. Odd place, even place, odd place, even place, odd place. Now what is my first step? So I will add the digits at the odd places. 8 plus 8 plus 9. Now it comes 25. Yes, 25. Now I will add the digits at the even places, 0 and 3. So 0 plus 3, what is that? 3. Now according to the rule, I have taken out the sum of digits at odd places. I have taken out the sum of digits at even places. Now what is the next? I have to subtract them. Now when you will subtract, you will get 22. Now is this 22 a multiple of 11 or divisible by 11? Yes. So this 22 is divisible by 11. So it means that 93808 also is divisible by 11. So this is how we check the numbers whether they are divisible by 11 or no. Now we come to the sixth question. In the sixth question, they are asking you which of the following numbers are divisible by 7. Now you should have to learn the divisibility rule of 7. Now what the rule says is double the last digit. Now let me start doing it and I will explain you. Now the first step is they are saying to double the last digit. What is the last digit here? 2. It means I have to double it. Means multiply by 2. So the last digit, when I multiply it with 2, it gets doubled. So it becomes 4. Now double the last digit I have done. Find the difference between double the last digit and the rest of the number. Now when I double the last digit, it has come 4. Now what is the rest of the number? The rest of the number is 45. So what I have to do is, now the rest of the number and the double of this digit which I have done, the double of the last digit which I have done, I have to subtract them. I have to subtract them. And now when you will subtract, what you will get? You will get 41. Now when I subtract, the difference which I get, the result which I get, is this divisible by 7? No, because 7 6 is 42. So this number is not divisible by 7. So it means that 452 is not divisible by 7. Again, one more, let me take one more number. Let me take the number 247. I will take 247. Now look at this 247. It means what the rule says, double the last digit. What is last digit? 7 multiplied by 2. It means the last digit I have to double it, means multiply with 2, and the rest of the number. What is the rest of the number? The rest of the number is 24. Usme se I have to subtract it. Let it me do like this. So what they are saying is, first to double the last digit. Double the last digit will be 14. 7 2s are 14. And now find the difference. I have to find the difference. I have to subtract between double the last digit. What is the double the last digit? That is 14. And the rest of the number. What is the rest of the number? It's 24. Right, now they are saying subtract it, find the difference. So when I find the difference, it comes to be 10. Now is this 10 divisible by 7? No, it doesn't come on the table of 7, not divisible by 7. So it means that 247 is not divisible by 7. It's not divisible by 7. Okay, now let me take the next one. Let me take 3, 2, 4, 8. Now what is my step? First step? First step is to double the last digits. 8 2s are 16. When I double the last digit, now this 16 I have to subtract from the rest of the number. The rest of the number is 324 minus 16. So this 16 I have to subtract from the rest of the number. So what you will get? You will get 208. 308. You will get 308. Now from this I cannot find out whether this is divisible by 7 or no. So what can I do is I can again repeat the process. Now this time with 308. Okay, so first the number was 3248, so I doubled the last digit 8 to the 16 and subtracted it from the rest of the number. So I got 308, but still I'm not sure whether this will be divisible by 7 or no. So what I will do is I will repeat the same process, but now with 308. So I will take the last digit 8, 8 twos is 16, and from the rest of the number 30. From the rest of the number, that is 30, I will subtract this 16. So what you will get? You will get 14. Now I can find out from 14. Is it 14 divisible by 7? Yes, this 14 is divisible by 7. 7 twos is 14. So it means that 3248 is divisible by 7. So this is the divisibility rule of 7. Now we come to the 7th question. A plot. You are given some numbers and they are asking you which of these numbers are divisible by 4 but not by 8. So among these numbers we have to find out whether these numbers are divisible by 4, which numbers are divisible by 4 but they are not divisible by 8. Now 4 ka divisibility rule we have already done, that we have to take the last two digits. If they are divisible by 4, it means that the number is divisible by 4. And for the rule of 8 says that we have to take the last 3 digits and divide them with 8. If they are divisible by 8, it means that the number is divisible by 8. Look at this. I will take 644. First of all, I will check with 4. Now what is the divisibility test of 4? That I have to check divide the last two digits. The number formed by the last two digits is 44, and check it with 4 whether it's divisible by 4. Yes, 4 11s is 44. So this 644 is divisible by 4. Now I have to check with 8. Now what the rule of 8 says, that the last 3 digits. Now this is a 3-digit number only, so I have to check this only. 644, 8 8 is 64, right? And you take this down 4 is not divisible by 8, so you will get the remainder 4. So it means that this number is not divisible by 8. So the question was which of these numbers are divisible by 4 but not by 8. So this number is divisible by 4 but not by 8. Okay, now let me take one more example. Let me take the next number, 3216. Okay, 3216. Now 3216 is this divisible by 4? Yes, because the last two digits are divisible by 4. 4 4s are 16. So this number is divisible by 4. Now to check the divisibility by 8. What is the divisibility rule of 8? I have to divide the last 3 digits. 216 with 8. 8 2s are 16 and 8 7s are 56. So this is completely, the last 3 digits are completely divisible by 8. So it means this number is divisible by 8 also. So this means 3216 is divisible by both 4 and 8. So what is the divisibility rule of 4? That I have to check the last digit on 4. So these two last digits are divisible by 4. So it means this whole number is divisible by 4. And the rule of 8 says that I have to check the last 3 digits. So I have to divide the last 3 digits on 8. So the last 3 digits are divisible by 8. So it means this number is divisible by 8 also. 7th ka B part, it says we have to check whether which of these numbers are divisible by 2 but not by 6. So I have to see that the number should be divisible by 2 but not by 6. Now first of all, the divisibility rule of 2, the number should be even. And how do I know that the number is even? By the last digit, right? 234. So if this number is even, the last digit is even, so it means this whole number is even, so it means this number is divisible by 2. Now I have to check its divisibility by 6. Now what is the rule of 6? That the 6, for the rule of 6 says that the number should be divisible by both 2 and 3, right? 2 and 3. Then the number is divisible by 6 also. If the number is divisible by both 2 and 3, the number is divisible by 6 also. So like 2 3s is 6. So I have checked the divisibility by 2, so this is divisible by 2. So now let me check with 3. What is the divisibility rule of 3? I have to add the digits. 9. So this number is divisible by 3, right? So it means 234 is divisible by 3 also. 3 also, so it means that this number 234 is divisible by 2 also, this number is divisible by 3 also. It means that 234 is divisible by 6 also. So it means the first number is divisible by both 2 and 6. Now let me take the second number, 7016. Now 7016, first of all, whether it is divisible by 2? Yes, because this is an even number. At the last, if you will see, it's an even digit. So 6 is there, this is even. It means the whole number is divisible. The whole number is even and it is divisible by 2. Now I have to check the divisibility by 6, and for 6 I have to check the divisibility by 2, which is already I have done, and now with 3. So with 3, what I have to do? I have to add all the digits, right? So you will get 14. Now is it 14 divisible by 3? No, it is not divisible by 3. So it means that 7016 is not divisible by 3. So now since this 7016 is not divisible by 3, so it means it's not divisible by 6 also. It's not divisible by 6 also. So this 7016 is divisible by 2, but this is not divisible by 6 because this number is not divisible by 3. So this number cannot be divisible by 6 also. So I have checked in the 7th B bar, I have checked that the first number 234 is divisible by both 2 and 6, but this number is not divisible by 6, though it is divisible by 2 but not by 6. Now I'll do the 8th question, A part. In this they are saying fill in the greatest digit to make the number divisible by 3. So here they have given you a box. Here they are asking you to fill in the greatest digit so that this number becomes divisible. Whatever number I get, that number should be divisible by 3. Now what is the divisibility rule of 3? I know that I have to add the digits. So 5 plus 3, I have 8 over here. 5 plus 3 is 8. So I have to add such a digit here that when I add all the 3 digits, it should be divisible by 3, right? So since I have to fill the greatest digit, so I'll start from the greatest digit. Let me fill this with 9. So 8 already I have. 5 plus 3 is 8. If I add 9 over here, so 9 8 is 17 ho jayega wo to. So that number will be divisible by 3? No. So it means 8 9 I cannot take over here. So now which is the next greatest digit? 8. So 8 plus 8 16. So if I add 8 over here, the sum will be 16, and then again the number is not divisible by 3. It means 16 8 I cannot add. Now let me take 7. 8 plus 7 will become 15. Now is this 15 divisible by 3? Yes. So it means if I add over here 7, this number will be divisible by 15. Okay, now let me take one more example. B part. Now here you are given 6 plus 5 plus 2. So I have to add the digits now. So it means I have 13. So I have to add the greatest digit over here so that it becomes divisible by 3. This number becomes divisible by 3. Now greatest digit, let me add 9 to it. 13 मेरे पास already है, so let me add 9 to it. So what do you get? 22. So 22 will not be divisible by 3. If this I add 9 over here, if I add 9 over here, so this sum will become 22, and 22 will not be divisible by 3. So it means I cannot take 9. So let me take 8 then. So if I take 8, it will become 21. So this is 21 divisible by 3. Yes, it is divisible by 3. So it means I can take over here 8. So the number will become 6528. Now look at this, the C part. Here again what I'll do is I will add the digits already I have. 5 plus 3 plus 3 plus 2, 13. Okay, now this gives me 13. Now 13 I start from the, because I have to put the greatest digit. So now the question is that what digit should I put over here so that this whole number becomes divisible by 3, and the greatest digit I have to put. So let me start with the greatest digit. So let me write over here 9. So what will get? 22. It means 22. It will become, if I add 9, it will become 22. The sum of digits will become 22, and it will not be divisible by 3. So I cannot add 9. So it means let me add 8. So it will become 21, and it will be divisible by 3. So it means if I add 8 over here, and this is the greatest digit, and after 9 it's the greatest digit, and when I will add, all these will become 21, and that will be divisible by 3. Now the ninth question. In the ninth question, like the 8th question, they have given you a box in which I have to fill the smallest digit this time to make the number divisible by 4. So the number should be divisible by 4. Now what is the divisibility test of 4? I know that I have to check the last 2 digits whether they are divisible by 4 or no. Now I have to add the smallest digit. So I'll start with the smallest digit, that is 0. So if I add 0, it will become 30. Now is this 30 divisible by 4? No. So I cannot add 0. Should I add 1? 31 it will become, and 31 is not divisible by 4. So I cannot add 1 also. Now can I add 2? Yes, because 4 8s are 32. So let me add 2 over here. So this will, the last 2 digits will become 32, and 32 is divisible by 4. So now 3, 4, 5, what should I add? The smallest digit I have to add. So if I will add 0, it will become 50. Now is this 50 divisible by 4? No. 4 11s are 44, and 4 11s is 44, 4 12s is 48, and 4 13s is 52. Right. So with 5, what should I add? I should add 2. So if I add 2, that number will be divisible by 4. Sorry. So this way also you can do. Now look at this. 104 here, the first digit. The first digit, if I add 0, will it be divisible by 4? No. If I add 1, 12, will this be divisible by 4? Yes. So I can add 1 over here. So this will become 12, and 12 is divisible by 4. So it means this whole number is divisible by 4.